In this session, we're going to very briefly cover interval notation, the belongs to, and the union symbols. More precisely, we're going to review the interval notation, and after that we're going to review how to switch back and forth between inequalities and the interval notation. One short disclaimer. If you are familiar with all aspects of this following notation, x belongs to the open interval from negative infinity to 7, union with the interval from 9 to 12, open at 9, closed at 12. So if you're familiar with every single aspect of the notation that you see in here, please feel free to skip the remainder of this lecture. Once again, if you recognize every symbol that you see written there, feel free to skip the lecture. More precisely, in this lecture we're going to cover the open, closed and semi-closed interval notation. So what do the parentheses here mean? What do the parentheses and the bracket here mean? What does the infinity symbol stand for in this notation? We're also going to cover what the belongs to symbol stands for, this symbol, the belongs to symbol. And finally, we're going to cover what the union sign stands for, this sign here, the union sign. Let a and b be two real numbers. I'm going to request that a be less than b. So I'm having two numbers, for example 1 is less than 2, so a could be 1, b could be 2. So let us take two numbers, the first one smaller than the second. So let us take two real numbers. The set of all real numbers from a to b is denoted as follows. So now I'm looking at the set of all numbers from a to b on the real line. So that set is an interval, and here's how I can denote it. So first I could take this set, the interval, so this is the number a on the real line, this is the number b on the real line, and I can take all points between a and b, including the endpoint b and including the endpoint a. That set, the interval from a to b, including the right hand point and the left hand point, is denoted as square bracket a comma b close square bracket. So that set is denoted as like this, square bracket a comma b close square bracket. So how is such an interval depicted? Either there are different styles, but the most frequently used styles are a line with the two endpoints denoted by solid dots, or a segment plotted like this with the two ends depicted with small brackets, similar to the brackets that we see here. So these are the two most frequently used notations for depictions of intervals. Okay, what do we do if we want to take all numbers between a and b? We want to include a, but we want to exclude b. So we want to exclude. So we want to throw out this point. So that point here, the exact point where b is located, is not included in the picture. Well, how do we denote that interval? Well, we denote it like this. We use square brackets near the included point, and we use an open parenthesis near the excluded point b. So if we take all numbers between a and b, including a but not including b, here's how we denote it, and here's the how we depict it. We make a solid dot at the place of a, and we make a hollow dot, a dot with a hole in place of the number b. Alternatively, we could put a square bracket at the point a and then an open parenthesis at the point b. These are the two most frequent depictions of this interval. A similar story is when we want to include the endpoint b, the right endpoint, but we want to exclude the left endpoint a. We just, when we want to exclude the point a, we draw a hollow dot at the point a and a solid dot at the point b, or a parenthesis at the point a and a square bracket at the point b. And once again, we use open parenthesis next to the point that is excluded and close square bracket at the point that is included. And finally, if we want to denote the interval which excludes both a and b, so we use open parenthesis at both a and b. And once again, we depict that by a hollow dot at the point a and a hollow dot at the point b. Now let a be a number. The set of all numbers greater than or smaller than a is usually denoted with the help of the infinity symbol. So this infinity symbol, like the number 8 but lying horizontally, this infinity symbol can be used to denote the set of all numbers greater than or smaller than a. So here's how we take the set of all numbers greater than a. So if we want to take the set of all numbers greater than a, but excluding the number a, so that corresponds to an infinite interval stretching from the number a all the way to infinity. So we denote that by putting an open parenthesis at the point a and making an arrow towards infinity to the right of the number a. And in our interval notation, we use open parenthesis for the point a, and we always use open parenthesis for the infinity symbol. Likewise, if we want to denote all numbers greater than or equal to a, so all numbers to the right of the number a, including the number a, we use a square bracket. So this square bracket means including a, and this open parenthesis means excluding a. Okay. Likewise, if you want to denote all points to the left of a, if we want to denote all points to the left of a, we use the negative infinity symbol. So the interval between negative infinity and a is depicted like this. Since we're excluding the point a, we use open parenthesis, and then we draw an arrow towards negative infinity to indicate the fact that we're including all points to the left of the point a. Finally, if we want to denote the interval between negative infinity and a, including the number a, we use square bracket. In this example, I'm going to teach you how to go from simple inequalities to the interval notation. We're going to actually do 3 examples. The first one is the following. Write the set of numbers x satisfying the two inequalities 0 less than or equal to x and x less than or equal to 2. So write the set of numbers satisfying that inequality in interval notation. So let's see how that is done. Here's the number 0, that is this number, and here's the number 2, that is this number. Now we're looking at all numbers less than or equal to -2, so we're looking at all of these numbers. and we are also looking at all numbers bigger than or equal to 0. So we also need to take a look at these numbers, and the intersection of the two intervals is this interval here, the closed interval from 0 to 2. So we see that our answer should be the closed interval from 0 to 2. Let's do another example. Let's write the set of all numbers x satisfying the inequalities -1 less than or equal to x less than 1. So let's see how that works. Well, x less than 1 corresponds to all numbers to the left of the number 1, excluding the number 1, and x, so that is this arrow, and the inequality -1 less than or equal to x corresponds to all numbers to the right of -1. When we intersect the set of points which satisfy both of these inequalities, we get this interval here. We have to include the point -1 because we have a non-strict inequality here, and we have to exclude the number 1 because we have a strict inequality here. So our final answer is the interval from -1 close brackets comma 2 to 1 with open parentheses at the number 1. Finally, let's solve a problem which involves the infinity symbol. Let's write the set of numbers x satisfying x less than 2 in interval notation. Now this is the set of all numbers smaller than 2, and those are form an infinite interval. So we need to have all points to the left of the number 2. So we start at -infinity, always open parentheses near the -infinity, and we go from -infinity all the way to the number 2. The number 2 is excluded because we have a strict inequality, so we need to use open parentheses for the number 2. So our final answer is the interval from -infinity to 2, open parentheses on both ends. In this slide, we're going to very briefly cover the definition of the union symbol. This symbol here is called the union symbol. Union symbol. So we're going to very quickly define that symbol. Let A and B be two sets. Now when I say two sets, I want you to think of intervals. Say this is the interval A and this is the interval B. So I want you to think of A and B as two intervals. However, the definitions that we're giving here are actually valid not only for intervals, they are valid for arbitrary sets, but we'll be using these definitions mostly when A and B are intervals. Okay, so let A and B be two sets. The union of A and B is the set consisting of the elements in A together with the elements in B without any additional elements. So you take those elements that belong to the first set A, so if A is an interval, so you take all the points in the interval A, you take all the points in the interval B, and no other points, so you don't add any extras. So that set, the union of the two, is called the union of the two sets. So that would be two intervals. If the two intervals do not overlap, the union of two intervals is two disjoint pieces. All right. So let us do a quick example. Let's plot all points in the set. Here we're -1 to 1, union with the interval from 2 to 3. So let's quickly plot the points in that set. So the set consisting of the interval from -1 to 1 is plotted like this. Remember, the point -1 is included and the point 1 is excluded, so I have to use close parenthesis on one side and open parenthesis on the other. And now the points in the interval from 2 to 3, I have to exclude the point 2 and include the point 3, so that gives me the set. That's how I depict the set, denoted here. So this is the set B, this here is the set A, and this is the union symbol. This is my union symbol, and I'm just getting these points together with those points, the collection of both these points. So the union of two intervals looks like, well, I guess like two intervals. Let's now plot all points in the set obtained by taking the interval from -1 to 2 and taking the union of that interval with the interval from 1 to 3. So here's the first interval, the interval from -1 to 2. The point -1 is included because of the close parenthesis, and the point 2 is excluded because of the open parenthesis. And let's also take the points from 1 to 3. So here's the number 1, here's the number 3. The point 1 is excluded, the point 3 is included. Now, as you can see, the two intervals overlap. In that case, there is no problem. We take one copy of each of the overlapped points. So the overlapped pieces, we don't count them twice or anything like that. We just take every point which belongs either to one set or to the other or to both of the sets. So every point which belongs to one of the two sets or potentially both of the sets, so every such point is counted. So the union of those two intervals is a single interval. So if two intervals overlap, it is possible that their union be a single interval. In fact, the picture that we just drew shows that the interval from -1 to 2 union with the interval from 1 to 3 is equal to the closed interval from -1 to 3. So our picture demonstrates that equality. Let A be a set. The notation that you see here, X, then this interesting symbol, and then A. So that notation is read as X belongs to A or as X is an element of A. So this symbol, the symbol that I just circled, the highlighted symbol here, that symbol is the belongs to symbol. So you read that symbol as belongs to. So what does it mean for X to belong to a given set? Well, that simply means that X is an element of the set, or X is a point in that set. Let's demonstrate that on an example. Let's express the statement that X is greater than -1 and less than or equal to 2 using the belongs to symbol. So here's how that works. We write that statement in the following way. X belongs to the interval between -1 and 2. We already discussed that the set of those X that satisfy the two inequalities is given by the interval open parenthesis -1, comma 2 close brackets. So we already discussed that that is the interval. What is new here is that we are indicating the fact that it is the variable x, not the variable y or some other variable. It is the variable x which belongs to the interval between -1 and 2. And the way we relate the variable x to the interval is via the belongs to symbol. So that belongs to symbol tells us that yes, it is the variable x that is between -1 and 2. Similarly, let us express the statement x less than 0 or x greater than or equal to 1 and x less than 2. So let's express that statement using the belongs to symbol. Again, we express the fact that we're talking about the variable x and not about the variable y or some other variable. So we express the fact that we're talking about the variable x as by writing x belongs to. So that expresses the fact that we're talking about the variable x. And next, we have to express the fact that x either satisfies this inequality, so x is less than 0, which would mean that x belongs to the interval between -∞ and 0, or x is between 1 and 2, including 1 and excluding 2, which means that x belongs to the interval closed on the right, open on the left, so closed interval 1, comma, open interval 2. So the fact that it is either one of the interval or the other interval means that x is either inside one of the intervals or the other, which means that x belongs to the union of the two intervals.